Are you interested in LoRa projects and applications? Then this is for you. In this episode, we will talk about testing LoRa boards for practical applications. We will cover the basic ideas, the software and hardware features, and the cases and the design of a nice idea. Our basic idea was to test out the LoRa data transmission capabilities of simple boards that you can buy for cheap. I wanted to check out the performance for some typical scenarios like indoors, outdoors and mixed scenarios. Experts know that a number of radio parameters like transmit power, receiver sensitivity, the so-called RSSI, SNR and others play a role here. We want to unmask this a bit and try to make them understandable and predictable in the coming episodes. We will provide calculations, code and tools, and of course we will also share some experience. I searched for some sense-making content to transmit via LoRa, instead of just sending counters and hello messages. And I found some powerful sensors for a reasonable price. The so-called BME 280 sensors are able to measure air temperature, humidity and pressure. The accuracy is much better than anything else in a usual household. With that, I realized that the data from the 3 sensors that I bought might be also really valuable. For sure, it will be worth an extra episode dealing with the evaluation of weather data. While designing an outdoor sensor entity, the issue of solar energy also became important. And you know that some of the past episodes are dealing with the dimensioning tools and the experience with solar powering. In relation to that, of course, battery characteristics like the state of charge became important. You will find also experience results and tools in the past episodes. Everything was measured and recorded using the given project. We created some interesting tools and also made some valuable experience that we partially already shared with you. Next, let's have a look on the software features that we need. Having a lot of experiments in mind, we need an interface to grab the data from a PC. We have 2 different ways to do that. One is via USB using a terminal interface. The other one, and this is much more convenient, is via Wi-Fi and a simple web server, which is also realized in the project. Now, instead of killing you with further details, I better show you the browser interface directly from a browser. Here is now the website that is recording our data. It appears in my local area network under the internet address that is under the top, and nothing is going into a cloud. As explained before, the data from the sensors is going via LoRa to our ESP32 web server, and then I can access it via my local Wi-Fi network. First, we have the current values as they are coming in from the sensors. We see the temperature, the humidity and also the pressure that is sensed by all the 3 sensors. You might have realized that the pressure is slightly different from the sensors. This is because the height level of the sensors differs slightly. And the sensor's accuracy is high enough to indicate that difference. Then we see the field strength level of the received LoRa signals. Having always buffer batteries in our entities, of course, we want to see the voltage level that the batteries have. And finally, we put a date and timestamp to each measurement. Our ESP32 board has got a lot of memory. We can store weather data from the whole year and bring it to our small website here. Next, we store here the minimum and maximum values floating over the past 24 hours. Then we look at the hourly values from the past 24 hours. Other interesting values would be the average values per day over the whole year, which is given here in the following. Finally, we look at some technical values here. The first word here under status is telling us that the scheduled Wi-Fi sleep mode is activated. For instance, I can tell my Wi-Fi adapter to go to sleep at 10 p.m. and then sleep for 9 hours. This means that it is going to wake up at 7 o'clock in the morning. Next we have the uptime here, which is basically telling us that the web server unit is running for 84 days now. Here is the Wi-Fi RSSI in dBm for our web server entity. Then we can see here the LoRa signal to noise ratio in dB and the LoRa frequency error correction in Hertz. The last value here is just the software version number of my own code. We can now read the data whenever we want with any kind of browser, or we can copy the complete browser window as shown here. And then paste it into a spreadsheet as shown here. And within a few seconds we have the complete website information on our spreadsheet. I am a great fan of graphics, and I want to give you some impressions of what you can do with the data here. For instance, you can investigate the temperature and the behavior of the humidity from one sensor. The time frame given here is 24 hours. And on the bottom here we see the pressure falling within the same time period. Then I always find comparisons cool. Here we see the outdoor temperature in blue, then the indoor temperature in red, and gray is the temperature in my garage. What I like most is to observe and compare the values over a longer time period. Here it is more than 60 days and I was observing the temperature again outside in gray, then this time in blue is indoor, and the red one is in my garage. I also observed the humidity, and this I did because I had some trouble with high humidity in my garage because the roof was leaky. But with my observation here over many rainy days, I think I can be sure that the roof is okay now. And of course we can also get the air pressure over the period. Another graphics is giving you now the proof for a very, very old rule. It is comparing pressure and temperature on a daily basis here. As we can see here, whenever the pressure is rising, then the next day the temperature is also rising over a few days. As soon as the pressure is falling, the next day also the temperature is falling. So the very old rule seems to be true, that with rising pressure the weather is getting better, and with falling pressure it's getting worse. And by the way, you might have seen the tendency on our little website, but this will be subject to a later episode where we will show how this is calculated. Now, having talked a lot about software features, we need now to talk a bit about the hardware. From our LoRa link, we expect at least 50 meters range, even under difficult circumstances. We want to test indoor, outdoor, deep basement, whatever scenario you can imagine. And we want to measure and record all the important radio parameters. And we want to test the suitability of different antennas, be it commercial ones or be it self-made ones. Here's the features listed for our outdoor sensors entity. The interesting information that is left on this one is that A, the antenna is mounted inside the case, and B, we sealed it as far as possible to make it absolutely waterproof. There is only small drill holes in the outer case for the humidity sensor, as can be seen on the left side on the case. The indoor sensor entity is similar to the outdoor unit. However, it is charged by a USB charger. And the antenna is on top of the case with an SMA connector. This gives us per se a better range, and we can test different antennas for better performance. In addition, it has got a switch to separate the battery completely in case we do not need it. You can see the entity here while charging, which is indicated by the red LED. The receiver and indoor web server is the central unit for the project. It stores the sensor data received via LoRa and has also a local sensor. On the OLED display, some of the most important parameters can be observed. Since the entity is connected to the local Wi-Fi network, the complete data is accessible via any browser in the local network, as shown before. On top of this, further technical and debug information can be received via the serial USB interface by a PC. Now let's have a few words about the design and the cases. Once we had done a rough layout, we created this design for the front panel. The cases for the three entities are all the same. Unchanged, without holes, they would be all waterproof. The front panel is fixed by 4 screws and has a ceiling. They are pretty sturdy durable and also gluable, which is really important. They do not break while drilling holes in it. The transparent front turned out to be really helpful, and they have a reasonable price on Amazon. We saw how to transform a basic idea into a little but structured project. Some ideas for a suitable design have been shared. Structure doesn't mean that you define everything in advance. It shall rather help you to separate the problems to solve and to keep your project open for the changes you want to make in the future. Finally, I have a recommendation for you. Try out something new, even when you don't know immediately why. It is often the basis for good new ideas. Further episodes on the realization of the project and LoRa experiments will follow soon. Now, stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.